and hi everyone. This video is for Mathematics 2 DM025 and it is about topic 1, limits. In this topic, there is only one subtopic, 1.1 limits. This video only covers 2 learning outcomes out of 5. So, at the end of the lesson, students should be able to A. State limit of a function f(x) as x approaches a given value a. B. State the basic properties of limit. Now, let's start our lesson. The first is about definition of limits. A function f(x) is said to approach a constant L as a limit when x approaches a, and the notation is as below. It is read as the limit of f(x) as x approaches a equal to L, where f(x) is the function which assumes a corresponding set of values and x is an independent variable. A key point with the limit concept is that we are not interested in the value of f(x) when x equal to a, but we interested in the behavior of f(x) as x comes closer and closer to a value of a. This definition will be explained more clearly in the first example. Example 1. Determine limit of x plus 3 as x approaches 3. First, we write function f(x) equal to x plus 3 to understand the concept of limit and the trace of the behavior of f(x) as x comes closer and closer to a. We use table. Since x is approaching to 3, so we put 3 in the middle of the table. Then we choose the 3 closest value from the left of 3. So we start with 2.9, 2.75 and 2.5. Then we choose another 3 closest value from the right of 3. That is 3.1, 3.25 and 3.5. Next, we substitute all the values of x that we have choose into f(x) equal to x plus 3. Then we obtain 5.5, 5.75, 5.9, 6, 6.1, 6.25 and 6.5. What we can see now is when x is approaching to 3 from left, f(x) is approaching to 6. And when x approaching to 3 from the right, f(x) is approaching to 6. Thus, as x gets close to 3, then f(x) equal to x plus 3 get close to 6. And this interesting situation called as limit, and it can be written as limit of x plus 3 as x approaches 3 is equal to 6. Limits also can be explained by using graph. Since we want to determine limit of x plus 3 as x approaches to 3, so we sketch the graph of f(x) equal to x plus 3, which is a straight line, where the x-intercept is -3 and the y-intercept is 3. Then, we find the value of y when x is equal to 3, so we get 6. Okay. Now, look at the graph. We want to know what happened to f(x). when x gets closer and closer to 3. We start from left. When x is approaching to 3 from left, so our graph is increasing and approaching to 6. When x is approaching 3 from right, our graph is decreasing and approaching to 6. Here we can conclude that when x comes closer and closer to value of 3, then fx approaches to 6. Therefore, this limit could have been determined by simply substituting x equal to 3 into fx equal to x plus 3. This means to find the value of limit, you only need to substitute value of x into fx. You do not need to draw a table or sketch a graph to get limit value. The table and graph shown just now are just to explain about definition of limit. So, the conclusion for this example is thus fx approaches 6 when x approaches to 3. In other words, it can be written as limit of x plus 3 as x approaches to 3, which is we can substitute x equal to 3 into x plus 3 and get the value of limit. Next part is about properties of limits. The first one is the constant function rule. If fx is equal to k, where k is a constant, then limit of fx, x approaches a, is equal to limit of k as x approaches a is equal to the constant k. The second property is if fx is equal to x, then limit of fx, x approaches a, is equal to limit of x as x approaches a equal to a. How to get this value of limit? We just substitute x equal to a into x. That's why we get limit of x, x approaches a is equal to a. The third property is if fx equal to x to the power of n, where n is a positive integer, then limit of fx, x approaches a, is equal to limit of x to the power of n as x approaches a is equal to a to the power of n. And this one also same with second properties, which is we just substitute x equal to a into x and then we get a to the power of n. Next, we will apply these properties in example 2. Find the following limits. A, limit 6 as x approaches to. B, limit x as x approaches 3. C, limit x cubed as x approaches 5. Okay, now we find the solution for example 2a. Okay, limit 6 as x approaches 2. So this one is the constant function. So the value of limit is the constant. So it is 6. Question B, limit x, x approaches 3. So we know to get the value of limit, we just substitute x equal to 3 into the function. So we get the value of this limit is 3. C, limit x cubed as x approaches 5. So we know we need to substitute x equal to 5 into x cubed. So we have 5 cubed. 5 cubed is 125. Okay. We continue with the other properties of limits. If k, a, b, and c are real numbers and limit fx as x approaches c equal to 8 and limit gx as x approaches c equal to b, then the first rule is the constant multiple rule. Means the limit of a constant times fx is equal to the product of the constant and the limit of fx. Second properties is sum and subtract rule. This rule states that the limit of the sum or subtract of two functions fx and gx is equal to the sum or subtract of their limits. The third property is product rule. This rule says that the limit of the product of two functions fx and gx is the product of their limits. And the last rule is quotient rule. The limit of quotient of two functions fx and gx is the quotient of their limits, provided that the limit in the denominator function is not 0. So now we will apply these properties in the example number 3. Okay, so example 3, we need to find the following limits. Okay, you are given 5 limits here. So we try to apply the properties one by one. Question A, limit 3x cubed as x approaches to 4. So for this example, we apply the constant multiple rule. So we can write as 3 times limit x cubed as x approaches to 4. So to get the value of limit x cubed, we know we just substitute x equal to 4 into the function. So we have 3 times 4 cubed and the value of the limit is 192. Question B, limit of x squared plus 5 as x approaches negative 2. And for this example, we apply sum rule. So we can write as limit x squared as x approaches negative 2 plus limit 5 as x approaches negative 2. So we have negative 2 squared plus 5 and the value of limit is 9. Question C, limit x cubed times x minus 1 as x approaches 4. And this example, we can apply product rule and can be written as limit x cubed as x approaches 4 times limit x minus 1 as x approaches 4. Next, we substitute value of x into x cubed and x minus 1. And last, the value of limit is 192. Question D, limit x over x plus 10 as x approaches 5. For this example, we apply quotient rule. So we can write as limit x approaches 5 over limit x plus 10, x approaches 5. Then we substitute x equal to 5 into the x and x plus 10. We have 5 over 5 plus 10 and we get 5 over 15. Simplify, it is 1 over 3. Last one, E. Limit square root of 2x minus 3 as x approaches to 3. And for this example, we cannot split 2x minus 3 because it under square root. So we just substitute x equal to 3 into x. So we get square root of 2 times 3 minus 3. Then the answer is square root of 3. Okay, that's all for this video. Thank you.